So in this video we are going to discuss third chapter matrices Vsaqs. First question, if matrix x minus 1, 2, y minus 5, z 0, 2, 1 minus 1, 1 plus a, which is equal to 1 minus x, so 2 minus y, 2, 0, 2, 1 minus 1, 1. Then find the values of x, y, z and a. Here given two matrices, given that the matrices are x minus 1, 2, y minus 5, and here z 0, 2 and 1 minus 1, 1 plus a, so which is equal to here 1 minus x, 2 minus y, and here this is z, so 0, 2 and here 1 minus 1, so 1 only. See, observe here, so in place of here we have to find the x, y, z and a values we have to find here. So here this is 1 minus x, this is 2 only, this is 2 and here also 2 here. See, observe that, so here both are 3 by 3 matrices only, both are 3 by 3 matrices, so that's why here corresponding elements are equal. So here x minus 1, which is equal to corresponding element is 1 minus x. So from this we can find the value of x. So x plus x is equal to here 1 plus 1, so 2x is equal to 2. So from this we get x is equal to 1. So again here, so corresponding element y minus 5 is equal to minus y. So from this here this corresponding element. So here, so y plus y is equal to 5. So from this 2y is equal to 5. So y is equal to 5 by 2. So here clearly the corresponding element z, so z is equal to 2 only. So that's why here z is equal to 2. And here to find the value of a, so a here, this corresponding element is, so 1 plus a is equal to 1. So here a is equal to 1 minus 1, which is equal to 0. So therefore here x is equal to 1, y is equal to 5 by 2. So z is equal to 2 and a is equal to here and a is equal to 0. See, like this we can find the x, y, z values. The next question is define the trace of a matrix and find the trace of a is equal to 1, 2, minus 1 by 2, 0, minus 1, 2, minus 1 by 2, 2, 1. So here, what is the trace of a matrix? So definition of trace of a matrix. So the trace of a matrix is defined as so the sum of the principal diagonal elements, the sum of the principal diagonal elements, in a square matrix is called trace of a matrix. The sum of the principal diagonal elements in a square matrix is called trace of a matrix. Here, given that, so to find the trace of this matrix, given that capital A is equal to here, so 1, 2, minus 1 by 2, and here 0, minus 1, 2, and here minus 1 by 2, 2, 1. See, what are the principal diagonal elements? These are principal diagonal elements. So now therefore, so trace of A is denoted by TR of A is equal to sum of the principal diagonal elements. So 1 plus minus 1 plus 1, so which is equal to 1 minus 1 plus 1. So plus 1 minus 1 gets cancelled 1. So therefore clearly we can say that so trace of A is equal to 1. Trace of A is equal to 1. The third question is, if A is equal to 1, 2, 3, 4, B is equal to 3, 8, 7, 2, and condition is given 2x plus a is equal to b, then find x. So here given that the matrix A is equal to 1 2 3 4 and the matrix B is equal to here, so 3872. Now condition is given here 2x. Since the condition is 2x plus a is equal to b, so from this you have to find the x matrix. That means so 2 into x is equal to, we can write b minus a. So now from this, so 2 into x is equal to matrix b is, we have 3 8 7 2 and minus matrix A is 1 2 3 4. Now corresponding elements, so subtracting here 3 minus 1 and 8 minus 2 and here 7 minus 3, so and 2 minus 4 we get here, so 3 minus 1 is 2 and 8 minus 2 is 6, 7 minus 3 is 4 and 2 minus 4 is minus 2. So now here, so 2x is equal to, we have 2 6, so 4 minus 2, and from this to get the value of matrix x is equal to, so here, so divide every element by 2, that is 2 by 2 and 6 by 2, so 4 by 2 and minus 2 by 2, so finally we get 2 by 2 is 1, so this is 3 and 2 minus 1, so which is the matrix X. The fourth question is construct a 3 by 2 matrix whose elements are given by, so Aij is equal to 1 by 2 into modulus of I minus 3j. So here, so you take that, let a 3 by 2 matrix, let a 3 by 2 matrix capital A is equal to, so considering that 3 by 2 means 3 rows and 2 columns, so this is A11, so here A12, A21, A22, A31, A32, like this. If you consider here 3 rows are there and 2 columns are there, this is a 3 by 2 matrix. Now here, so one represents the rows and second one represents the columns. So here we have given, we have Aij is equal to here, so 1 by 2 into modulus of I minus 3j. So I minus 3j this is. So from this we have to find the elements now. So first element finding A11 is equal to, so here I is 1, j is also 1. So 1 by 2 into modulus of, this is I is 1 minus 3 into 1, so which is equal to 1 by 2 into here 1 minus 3, so which is equal to minus 2. So modulus of minus 2 is always plus 2. So that's why 1 by 2 into 2, so which is equal to 1. So A11 is equal to 1. Similarly, here you have to find the A12. A12 is equal to, so 1 by 2 into, here I is 1, so j is 2, so that's why 3 into 2, so which is equal to 1 by 2 into, here 1 minus 6, so which is equal to 1 by 2 into 1 minus 6 is, which is 5, minus 5 this is, so here modulus of minus 5 is always plus 5, so that's why A12 is equal to 5 by 2. A12 is equal to 5 by 2. So similarly here we have to find that, so A21 is equal to, so here 1 by 2 into, in the same condition, I is 2 minus j is 1, so that's why 3 into 1, so which is equal to, we get, so 1 by 2 into, so this is 2 minus 3, 2 minus 3 is minus 1, so 1 by 2 into modulus of minus 1, that is plus 1 only, which is equal to 1 by 2. And similarly A22 is equal to, so 1 by 2 into, here I and j both are 2 only, so that's why in the same condition I is replaced by 2 and j is replaced by 2, so we get here 1 by 2 into, so this is 2 minus 6, and here minus 4. So 1 by 2 into this is minus 4. So which is equal to 4 by 2. So 4 by 2 is 2. And similarly here A31. So A31 is equal to here. So I is 3 here, J is 1. So A31 is equal to 1 by 2 into modulus of I is 3 and J is 1. So that's why here 1 by 2 into, so this is 3 minus 3, which is equal to 3 minus 3 is 0. So that's why 1 by 2 into 0, so which is equal to 0, 1. Next A32. A32 is equal to 1 by 2 into modulus of I is 3 minus J is also 2 here. So 3 into 2 here, which is equal to 1 by 2 into 3 minus 6. So which is 1 by 2 into this is minus 3. Modulus of minus 3 is plus 3 only. So that's why 3 by 2. See, we get like this. So therefore capital A is equal to, we have so A11, A12, A21, A22, A31 and A32. So in this corresponding elements, if you replace A11 is equal to 1 and A12 is equal to 5 by 2, A12 is equal to 5 by 2 and A21 is equal to 1 by 2. So and A22 is equal to 2, A31 is equal to 0 and A32 is equal to 3 by 2. So which is the required 3 by 2 matrix. The next question is, if A is equal to minus 1, 3, 4, 2, B is equal to 2, 1, 3, minus 5 and X is equal to X1, X2, X3, X4, then A plus B is equal to X given condition. Find the values of X1, X2, X3 and X4. So here given that the matrices are capital A is equal to here, so minus 1, 3, 4, 2 and B is equal to here, so 2, minus 2, 1, 3, minus 5. So X is equal to, we have here, so X1, X2, X3, X4, so the matrix X. But what is given here, A plus B is equal to X. So this is given condition. So what is A plus B? So the sum of the two matrices. That means here matrix A is minus 1, 3, minus 1, 3, 4, 2 and plus matrix B is here 2, 1, 3, minus 5. So which is equal to the X matrix, that is X1, X2, X3, X4. So now adding the corresponding elements here. So this is minus 1 plus 2 and here 3 plus 1 and here 4 plus 3, 4 plus 3, 2 plus minus 5. So adding the corresponding elements here. So which is equal to here X1, X2, X3, X4, the matrix. See, observe here we get minus 1 plus 2. So which implies 1 and 3 plus 1, 4, 4 plus 3 is 7 and 2 minus 5 here, that is minus 3. So which is equal to X1, X2, X3, X4. See here both are 2 by 2 matrices only. So that's why, so if both the orders is same, the matrix order of both is same. So that's why the corresponding elements are equal. So therefore we can say that, so X1 is equal to 1, X2 is equal to 4, X2 is equal to 4. Corresponding elements are same if order of the matrices is same. X3 is equal to 7 and X4 is equal to, so minus 3. See, like this we can find the X4 is equal to minus 3. So like this we can find the X1, X2, X3 and X4. Next question is, if X minus 3, 2y minus 8, Z plus 2, 6, this matrix is equal to matrix 5, 2, minus 2, A minus 4. Then find the values of X, Y, Z and A. See here, if you take the given matrices, so X minus 3, 2y minus 8, Z plus 2, so 6. So this is a 2 by 2 matrix which is also is equal to 5, 2, minus 2, so A minus 4. So this is also 2 by 2 matrix. So both matrices order is same. So that's why corresponding elements are equal. Here corresponding element is now x minus 3 is equal to 5. So from this we get x is equal to, this is 5 plus 3. So from this x is equal to 8 we get. And similarly here, so 2y minus 8, this corresponding element is equal to 2. So from this 2y is equal to 2 plus 8 and 2y is equal to 10. So y is equal to 10 by 2 which is equal to 5. So therefore y is equal to 5 we get. And similarly here the corresponding element is z plus 2 is equal to, here corresponding element is minus 2. So now z is equal to here minus 2 and this also minus 2. So now z is equal to minus 4. This is the corresponding elements. Then so now next corresponding element is 6 is equal to a minus 4. So from this 6 plus 4 is equal to a. So 10 is equal to a. So therefore a is equal to 10. So like this we can find the x, y, z and a values. Seventh question is, if a is equal to matrix 1 2 3 3 2 1 and b is equal to 3 2 1 1 2 3, find 3b minus 2a. So here given that matrix A is equal to 1 2 3, so 3 2 1. So and b is equal to, so given 3 2 1 3 2 1 1 2 3, so 1 2 3. So now 3b minus 2a, 3b minus 2a which is equal to 3 into matrix B. Matrix B is we have, so 3 2 1 and 1 2 3 here minus. So 2 into matrix A is, we have 1 2 3 1 2 3 and 3 2 1 1 2 3 and 3 2 1. So which is equal to, this is multiplying every element by 3. This is 9, 3 into 2 is 6, 3 into 1 is 3 and here 3 into 1 is 3, 3 into 2 is 6 and 3 into 3 is 9 and minus here. So multiplying every element with 2. So this is 2 and 2 into 2 is 4 and this is 2 into 3 6, 2 into 3 is 6, 2 into 2 is 4 and 2 into 1 is 2. So now, so subtracting the corresponding elements, here 9 minus 2 and 6 minus 4 and 3 minus 6. So here 3 minus 6, so 6 minus 4 and 9 minus 2. So what happens here, which is equal to, we get, so 9 minus 2 is 7, so 2 and minus 3 here. So this is minus 3, 3 minus 6, 6 minus 4 is 2, 9 minus 2 is 7. So like this we get, therefore, so 3b minus 2a which is equal to, we get 7 2 minus 3 2 7. So like this we can find. So next eighth one is, the question is, if a is equal to I 0 0 minus I, then show that a square is equal to minus I. So here given that matrix A is equal to, so I 0 0 minus I, so A is equal to I 0 0 minus I. So now A square is equal to, we have to multiply the matrix A 2 times, which is equal to I 0 0 minus I. So into again I 0, so 0 minus I. So then if you multiply, this is first row, first column, suppose if you multiply, so this is I into I and plus 0 into 0. Again first row, second column multiplying here, I into 0 and plus 0 into minus I, plus 0 into minus I. So second row, first column multiplying, so that is 0 into I plus here minus I into 0, and second row, second column multiplying, that is 0 into 0 plus minus I into I, minus I into minus I, so which is equal to, so we get A square is equal to, so here I into I square and plus 0, and here 0 minus 0, so then here 0 minus 0, Again here 0 minus into minus is plus, I into I is I square. So here we get clearly a square is I square 0 0 I square. So we know that I square value is equal to minus 1. So that's why I square is replaced by minus 1, 0 0 minus 1. So here the value of I square is equal to minus 1. So that's why here a square is equal to we have so minus 1 0 0 minus 1. So which is equal to, if you take minus common, it can be written as 1 0 0 1. We know that 1 0 0 1 is the unit matrix, it is denoted by I only. So that's why, so clearly we can show that a square is equal to minus I. So next question, if a is equal to 2 4 minus 1 k and a square is equal to O, that is null matrix, then find the value of k. See here, given that matrix A is equal to 2 4 minus 1 k. So now here a square, first I am finding a square. A square is equal to a into a, which is equal to 2 4 minus 1 k into again 2 4 minus 1 k. Both are 2 by 2 matrices. Matrix multiplication is possible. So which is equal to first row, first column, if you multiply 2 into 2 plus 4 into minus 1. Again first row, second column, 2 into 4 plus 4 into k here. So now second row, first column, that is minus 1 into 2 plus minus 1 into 2 plus k into minus 1 plus k into minus 1 here. And second row, second column, so minus 1 into 4 and plus here k into k here, k into k we get. So which is equal to, clearly we get, so here 4 minus 4 and here 2 into 4 is 8 plus 4k and here minus 2 minus k and here minus 4 plus k square plus k square. So this is a square is equal to, we have here, so 0 and this is 8 plus 4k and here minus 2 minus k and here minus 4 plus k square. See what is given here, a square is equal to O. So therefore, so given here the condition, since a square is equal to O, so from this what is we get a square, here we have a 0, so 8 plus 4k and minus 2 minus k and minus 4 plus k square which is equal to, so the null matrix is here 0 0 0 0. So that's why here corresponding elements are, if we equate, so 8 plus 4k is equal to 0. From this 4k is equal to minus 8. So from this we get k is equal to minus 2. Again corresponding element is here minus 2 minus k is equal to 0. From this minus 2 is equal to k. So that implies k is equal to minus 2 we get. And here minus 4 plus k square is equal to 0. From this k square is equal to 4. But here k is equal to, we can take plus or minus 2. So that means finally what we have to take here. So if k is equal to 2, so that implies a square is not is equal to null matrix. See here. So if k is equal to 2, here 8 plus 4 into 2, that is 8. So here minus 2 that is minus 4 and here 0. So that's why when k is equal to 2, a square is not is equal to O. So if k is equal to minus 2, so then that implies a square is equal to null matrix. See here, k is minus 2, 8 minus 8, 0. And k is minus 2 plus 2, that is 0. And k is minus 2 here, minus 4 plus 4, that is 0. So therefore, if k is equal to minus 2 only, a square is equal to O, null matrix. So therefore, k is equal to minus 2 only we have to consider. K is not is equal to plus 2. Next, 10th question is if A is equal to 3, 0, 0, 0, 3, 0, 0, 0, 3. So then find A to the power of 4. So here given that A is equal to 3, 0, 0, 0, 3, 0, 0, 0, 3 and we have to find the A power 4. So now A is equal to, if you take 3 common from this, we can write 1, 0, 0, 0, 1, 0. So 0, 0, 1. So this can be written as A is equal to 3 into, we know this 1, 0, 0, 0, 1, 0, 0, 0, 1 is unit matrix I. To find the A power 4, so operating whole power 4 on both sides, whole power 4 on both sides. So then we get here, so A to the power of 4 is equal to, A to the power of 4 is equal to, this is like AB whole to the power of m. So that is 3 power 4 into I power 4. We can write here, suppose AB whole to the power of m is equal to A to the power of m into B to the power of m. Same like that, 3I whole to the power of 4 is equal to, so 3 to the power of 4 into I to the power of 4. And A power 4 is equal to here, 3 power 4 is 81, 3 into 3 into 3 like that, 4 times. So into I power n is equal to I only. I power n is equal to, always we get I. So that's why here this is also I power 4 is also is equal to I only. So that's why 81 into I. So finally if you write, so 81 into, again unit matrix 1, 0, 0, 0, 1, 0. So 0, 0, 1 if you write, then finally we can write A power 4 matrix is equal to 81, 0, 0 and 0, 81, 0 and 0, 0, 81. So like this we can find the, so matrix A to the power of 4.